So as I was talking about in the last video, ventilation and perfusion are highest at the base, yet the VQ ratio is highest at the apex. Now why is that? So as you can see in this graph, what happens is you have both ventilation, right, and perfusion highest at the base, yet the ratio actually increases because ventilation goes down and so does perfusion, but the ratio, as you can see, switches, and so V is actually higher than Q because Q goes down faster than ventilation, and so the ratio is higher at the apex than at the base. And so this is an important concept to remember for exams. So I'm just going to go on to the next subject, or the next thing on my notes. So we'll be talking about CO2. So CO2 is mainly transported in 5 different ways. The most important, which would be bicarbonate, HCO3 minus, but it's also carried as just dissolved CO2, which is around 5%. You also have carbonic acid and carbonate. Both are not that important for CO2 carriage, but I think you should know about them. And then the other important one is carbamino compounds like carbaminohemoglobin, which is just a CO2 bound to a hemoglobin. And so this is around 20%. So a lot of the CO2 is formed into H2CO3, and then it dissociates into HCO3 minus, which is bicarbonate. And this is around 64% of all CO2 carried in the blood. And so how is this formed though? This is formed by carbonic anhydrase, and this is found in red blood cells. Also, there's a HCO3 transporter for red blood cells, and so the newly formed HCO3 is actually pumped out of the cell, which creates more HCO3. So this is important for creating a buffer in your blood. And so once again, this is just a reiteration that ventilation and perfusion are higher at the base, but the VQ ratio is higher at the apex. The next thing I'll like to talk about is just how to approach problems in the respiratory module. So you try to look for buzzwords. For example, increased fremitus is usually indicating pneumonia because not a lot of other conditions have increased fremitus. Usually it's decreased fremitus, for example, for pleural effusion or pneumothorax. So increased fremitus would clue you in that it's pneumonia. Next, if they give you an ABG, arterial blood gas, you can use this formula, the PaO2, the large A standing for alveolar, and then PiO2, which is inspired oxygen. So in general, it's 760, the pressure in the atmosphere, minus 47, which is taking into account the partial pressure of water, because the oxygen you're inspiring is also hitting the moist trachea, so that would count as the water. And then you multiply it by 0.21, which is the percent of oxygen in the air. And then you subtract PaCO2 divided by 0.8 to find the AA gradient. So now, and then they have to give you the oxygen, because then once you get this, it'd be the PaO2, right? So it'd be the alveolar oxygen, but then you would need that PaO2, like the arterial oxygen, and that's something that they would have to give, and then you subtract those two to get the AA gradient. So if it's normal, then you can narrow your differential to hypoventilation and high altitude, because these two are the only ones that have a normal AA gradient with hypoxia. If the AA gradient is increased, if it's greater than 12 to 16, which is the general normal for AA gradient, then it can be 3 things. It can be VQ mismatch, so my acronym is PAPA, so it can be pneumonia, atelectasis, pulmonary edema, or ARDS. It can be a shunt, so it can be pulmonary embolus or cardiac shunt. Or finally, it can be diffusion, so my acronym here is PIP, so pulmonary edema, interstitial disease, fibrosis, or it can be pulmonary hypertension. So why does this cause diffusion problems? Because they have thickened vessels, so that would affect the diffusion rate. So this is an important clue that they like to give. Shunt is the only one that does not correct with oxygen, so it can be a clue if a patient gets oxygen, for example, if they have hypoxemia, and then they end up not improving with that. So this can indicate that there could be a shunt involved. I'll continue in the next video, and thank you for watching, and I hope it helped.